Good afternoon, everybody. Today I will present my Flying U innovation project, the Good Transportation System. Firstly, I will say about my introductions and the purpose of the projects. The world in 2020 and 2021 has witnessed a huge challenge in many industries. The COVID-19 caused a several block in the supply chain. In addition, the growth of e-commerce also increased the industry of fast delivery. We have recognized the need for a automate, fast and efficient form of good delivery. And the first reason why I come up with this project is the market demand. According to the book Global Logistic Market 2021 to 2025, the global logistic market values will grow by 70 billion dollars during 2021 to 2025. One of the factors that's driving this growth is COVID-19 and the rise of e-commerce. It also creates the need for fast urban delivery. If you look at the statistic right here in 2011, people spent about $2.5 trillion in urban logistics, and in comparison to 2020, we spend about $5.9 trillion in urban logistics. The numbers is forecasting to be keep rising in the future. So the demands for a fast deliveries in urban area is clear. The second reason why I chose this project is the Uber's ecosystem has already a advantage to developing this project. It has a good brand image with available shipping service. In addition to the high density of Vertipot networks available, these projects will have expand the company service ecosystems as well as make the most available resources to be profitable for a long time in the future. So the need for a fast urban delivery for Uber is clear. I will move on to the system requirement. Like other shipping industry products, safe and low costs are the minimum requirements. It also needs to be able to hold the payload of the package. In addition, a fundamental element for this project is that the good transportations by aircraft and Vertiport is built on top of a tall buildings. Therefore, a important requirement is that the system need to be safe a lot of time and space, as well as avoid disturbing customers. Next, I'll talk about the design. As the requirement has been clear, I will talk about the design of the truss system and a cargo box. The truss system has two parts, the front part and the back part. What you look at right here is the back part. We can link the truss into the belly of the aircraft by screw and drive. And this part right here is a representation for a hook, which we'll use to link into the cargo box, which I will present later. The truss is made of alloy steel, which made the total weight about 5.1 kilograms. It can carry maximum 600 kilograms, and while working carries about 250 57 kilograms. This is the front part of the system. It's also made of alloy steel, have a total mass about 1 kilograms. It can carry maximum 400 kilograms, and the working load is about 257 kilograms. This is the cargo box design. It's made of wood, and it's made of wood with about 3 cubic meters big, and which made it a total weight of 150 kilograms. The working load is 400 kilograms. The box design, the way that we can slide the bottom of the box out along with the good inside the box, so that it will save a lot of time to unpackage. In summary, the total weight of the box and the truss system is 121 kilograms. It can carry about 400 kilograms of products inside the box, and the truss itself costs about $3, including the material and the manufacturing. Wood box is also costs about $100. This right here is the Vertipot design. The Vertipot have 2 floors. The upper floor is where the floor for aircraft preparations and passengers to on board. There's holes between 2 floors so that when the aircraft is landing vertically, the package can pass through the holes into the lower floors. The lower floor will have a box rack for unloading package. This vertical system not only saves time and space, but also take advantages of the condition of high-rise buildings. Next is the operation circle. The circle begins when the aircraft starts to land vertically, while the box under the aircraft, loaded with 400 kilograms of products, is passing through the holes. When the aircraft wheel hits the ground, the box is supported by the supporting table. The support table will slide the bottom of the box out along with the goods in the box, and then automatically drive into the warehouse, where there are staff ready to unpack and load new items into the supporting table, and the table automatically return the new item into the box. Meanwhile, upstairs, the aircraft is being checked and ready for new passengers to on board. The aircraft take off carrying passengers and cargoes to the next point, where news circle begin. Here I have done some quick evaluations of the system. This is a small comparison between the truss and cargo box system and the normal van. The truss and cargo box system have the loading ability of 400 kilograms and 3 cubic meters, while the normal van can carry about 650 kilograms along with 5.5 cubic meters. The travel time from Marina to downtown, calculated by the Uber company themselves, is about 50 minutes with the aircraft and 1 hour 40 minutes with a normal car. And finally, the loading time is mine conjecture. The truss and cargo box needs about 50 minutes to unload and loading new item, whilst a traditional van need about 1 hour and 30 minutes. Is can be seen from the table above that is prove itself to be a efficient, fast delivery method, although a little less in volume each time. The parts on the aircraft is all made from common material like steel and wood, which reduce the cost of the part. The processing is also very simple, easy to mass produce. The vertiport is designed that the numbers of cargo pickup point is equal to the numbers of landing points. By taking advantage of the lower floor of high-rise buildings, saving a lot of horizontal space on top of a buildings, unloading time considered with aircraft preparation time and is automate most of it. So the process of preparing goods for the next flight only takes about 30 minutes, much faster than the average van loading and unloading time. Therefore, my conclusion is it have met every requirement listed above. Finally, I will talk a bit about the future works. A innovation project like this takes about 1 to 4 years to complete. So after nearly a month of research, is clearly that it's had a lot of work to do. First, I think we need to study more closely about the needs of the markets as well as the requirements of potential Uber partners in the future if this project goes commercial. Uh, in the design sections, we need more tools to test and evaluate the effectiveness of the design as well as in mass productions and the costs. The simulation and evaluation should be done to say whether the safety standards are met. We should also not forget the artistic aspect of the products. In particular, the vertiport design also need more research on construction technologies on a high-rise buildings as well as the effectiveness of the design. Because as I know, as is not every building can be modified to build this vertiport. Finally, we need simulations and a detailed methods of evaluating the performance of the entire working circle. That's everything I wanted to say. Thank you for your attention. I'm looking forward to hear comments from you.